All right, so on this first question, we have grass clippings where they decompose, and it's modeled, the amount of grass clippings is A of T. So A of T is not the rate, it's the amount of them. A is measured in pounds and T is measured in days. The average rate of change of A of T is, so let's look at what our golden notes say. This is average value, okay? So if you want to know the average value, like the average amount that was in there, since A of T is the amount, this right here would be the average value or the average amount that was in there. But if I'm doing the rate of change of a function, the rate of change, the average rate of change is just, if it's of x of t, it's just the slope, right? So if I had velocity, this would be the average velocity would be with the position. But if I'm doing average rate of change of a certain function, it's just the slope of the function. So when we got to this one, you were just supposed to do the slope. So some of you did the average value, which would be the average amount of things that were in there. And if you look at the units, you can tell by the units as well. Like if I did this one that you guys did on it, you guys did this, right? For number one. Well, what are the units for A of T? Pounds. And what is dt going to be? Days. So pounds times days. And then this right here is going to be measured in what? It's 1 over 30. What was 30? Days. So this is 1 over days. So this right here, if you do this, this is the average pounds. So that's the average pounds, not the average rate of change of this function. So average rate of change of a certain function is just the slope of that function. Okay? So that one, whoever did that first, up there, you guys were right, and everyone else kind of agreed with this one, but this one was the wrong one. It was supposed to just be slope. So good job, whoever did that, and think about it. Don't always go with the flow, just because 4 people checked it, doesn't mean you guys check it. So it was, and then you would need to make sure you did pounds per day. So if you would have looked at this, you would have seen that it wasn't pounds per day. Okay, and it would have made sense to not just put that as the answer. So it had to be pounds per day. The next question, find the value 8 prime of 15. Some of you probably just went, yep, they put it in the calculator, good. But make sure you don't forget how to put it in your calculator. So everyone grab your calculator, and I want you to put in 8 prime of 15. Make your calculator find that value, and make sure you know how. Okay, so if you read through the question first, you know that you have more things to answer. So I'm putting it into my y1 so that I can just keep referring back to y1 and it will make it easier. Oh, I can hit y1, we'll do it. And then where do we go next after this? How do I find the value of the derivative? Math 8. Okay, so the value by variable x, and I'm just going to put y1 alpha s squared, maybe? Yep. Oh, not right there. So I'm finding the value of the derivative at x equals 15. So there's my answer. So just go to 3 decimal places, negative 1.163. And all you have to do to show your work is just say 8 times 15 equals that number, and you're good. And if you, well, I guess we got to interpret it. So that value would be worth 1 point, and then this is another one that, this is kind of a tricky thing. You know how when you're talking, that it's decaying, it's decomposing, but you can't say it decomposes at a rate of negative 0.164 because you're doing a double negative. If you say decaying at a negative rate, that means it's not decaying, it's going up. So you've got to either say this is the rate it's going, or if you say the grass clippings are decreasing at a rate of this, or decaying or decomposing at a rate of positive 0.164. You can't say decaying and negative in the same sentence. It goes the opposite, right? So that's kind of a tricky thing to get that part right. Or you could say the rate at day 15, and you have to make sure you say 15, at t equals 15, or at day 15, the rate that it, I don't know, I'm trying to think how you can say it without saying decaying. The rate that it's increasing is a negative 0.164. It should say it's increasing at a negative rate, or decreasing at that positive number. Okay, so that's tricky. So this next one, find the time for which the grass clippings is equal to the average amount of grass clippings. So we have to find the average amount, which we talked about was, this was your average amount. So the average amount, you have to show this right here, which you guys did, right? That is your average amount, so that part would be worth 1 point. But once you find your average amount, what did we get for our answer back there? The time, you got the right time. But you got to make sure that you got 12.436. That's not right. See? So you're off. You're close. Someone did something kind of right, but they didn't finish it right. So we need to find this average amount. So let's do that. Let's do the integral. Oh, I didn't divide by 30 yet, but that's okay. 0 to 30 of alpha f4 okay, so this divided by 30 is my average amount. So here's my average value of what was in there. Nope, sorry. Okay, and I need to know when the amount was this, at what time. So I'm going to store this. This is the average amount. I didn't do it yet, did I? No, it's good. Is it supposed to, oh, I divided by 30. Okay, divide by another 10, sorry. Okay, so this is my average amount, right? So I'm going to store that value to A. So now when I come to y equals, I have this graph, and I have this value. I need to know when they're the same. So this is the amount of grass clippings. This is what it is. So now if I just graph that, and I don't know what my graph's going to look like. Okay, so I'm going to see where they cross. I can't tell if they're crossing yet right there, so I'm just going to move my window out a little bit. Or slice it, whatever. So I can see where they cross, and then I just take my calculator, calculate, intersect. So calculate, intersect, that, whatever. So at 12 find your slope of that line? The derivative, yeah, a prime of 30, right? That's your slope. So if I do y minus y1 equals m times x minus x1, these are just numbers, so you can either say what these are. They said it right here. This is the slope, and this is the point. Alright? And so you just type it in your or write down y minus y1. What's my y coordinate of my point? This one. Yes? So you could say a of 30, or if you have this written down, whatever you want. You know what I mean? I can write a of 30, or I can write that number. I'm just going to write that number, I guess. Equals the slope, which is a prime of 30. Times x minus my x coordinate, which is 30. Right? So there is, if you write, and then it said make that be L of t. Now what does it say? L of t equals, so this would be L of t. So if I move that y over, then I could say L of t equals y theta. So they did it like this. Did it like this. And then make sure that you actually answer the question. It wants to know at what time will there be 0.5 pounds of grass remaining. You have to take your equation that we just had. You could probably just set it equal to, set this equation equal to 0.5 and solve it. So either with a calculator or however you want to solve it. You can still graph it again and see where they cross if you want, or you could just solve it. It's just a linear equation. Shouldn't be too hard to solve. Alright? And be careful that you are accurate. Like I would maybe store these values so that you could do it more accurately so you get these decimals. Or maybe if you use 6, probably be okay, but you might lose store. So make sure on question 2, we got it right, everyone checked it and checked the decimals, and that was good. I don't know if my other class did that, but you guys were good at going through. But make sure you realize there's going to be one like this. It's been on the last couple tests. So you have something, you need to find out where they cross. So you can see, this one happens to be all dx. Everything they do is dx. But remember, you could, if you did it in terms of y, you just have to go from the y coordinate to the y coordinate and find the area and stuff. And it has to be in terms of y. But make sure you show where they cross. If you want. This is all they did. They said the function equals 4 because you have the line 4 at x equals these two numbers. So they did that, or you could do, what's this one right here? 2.3. And if it's just simple numbers like that, you probably don't need to do a and b. Because if it's just 2.3 and 4, you can just use 2.3. There's no sense doing 2.3 equals a because 2.3 is super easy for us. And this one was 0.4. So just kind of, you can even mark those so that you know as you go look at it. And then remember that volume is pi, and then you got to do the big R squared minus the little r squared. I got so many parentheses there. But don't forget you do pi r squared for your cylinder. Goes around, and then minus pi r squared. So everyone did pretty good on that. It went around this line, and don't forget to do top minus bottom. So 4 minus -2. And then, so that's the big R, and then the little r is f of x minus -2 squared. And you will get, look at all these points just for that. 4 of the 9 points right here. So you got the limits. So somewhere if you have the limits in one of the things, right, you'll get the limits. Your answer will be 1, and then doing this right. And I think below it might even say like you get a point for want is make sure they give you. The second one pops up right isosceles triangles. So you guys were good to remember that the area of a right triangle was 1/2 x squared, right? So that was good. So that's how you got the 1/2 right here. And then this was the x squared, because your x was top minus bottom. This is how big that is. And then integral from 0 to 2.3. So they give you point for having the integral and point for the answer. So that's a lot of points just on this question. You guys are pretty good at these, I feel like. Yeah, we can do a lot. I'm kind of glad that we did the one like this before on your test, right? That was hard and it kind of threw it at you and you guys, a lot of you missed it, but somebody came up with it. But I feel like that it's not so bad now, right? The area, when you find the area, but you go from 0 to k and then k to 2.3 is supposed to be the middle. So just don't forget that this is just area now, so you just got to do top minus bottom. Nothing too tricky. Area of a rectangle. Is 4 minus f of x. So you don't have to put, remember you can just, if it says f of x, there's really no reason to write all of that out. Just write f of x. It's way easier. And then just keep that in your y1 as you're working it and do your integrals. So, okay, so here's you guys, we got 9, we got a 9.5, 10, 9, everyone goes switching back and forth, right? Okay, so let's figure out what it's supposed to be. Alright, so the question is, find g of 3. So g of 3 is going to be the area underneath that from negative 3 to 3. So you got to make sure you go the right place. So I'm going, maybe I would just say, mark on here, I'm going to there. Right? So I have 1/2 base times height. This is 3 times 4. I think everyone was fine with this part. It was just this part over here that was crazy. So this is a positive 6. And then this is 4 times 2. Half of it's 4. Now right here, you've got to figure out what the heck this is, because you're subtracting off that. Because you had to go, this only went to 2, so it wasn't 10. That's 10 right there. You've got to subtract something off. Look at the slope. It goes down 4 over 2. So this is going to go down 2 over 1. So that's what this is, 2 and a 1. So this area is 1. And I'm subtracting it because it's underneath. So it's 9. Because it goes 2 3. Oh. So this is the part that gets confusing in my head. I need something to help me out. Like, if I have, what interval is the graph of g increasing and concave up? The thing you have to realize is that f, since g is the integral of this, this is g prime, right? So if you can make that connection, and I would write it down just for myself and for them, so that they know that you know that if you take g prime, which is the derivative of this, the derivative of the integral, this gives you back to the function. So g prime is this. So that actually, I think, might have been some of the points too, is to say, they didn't actually, they just said, they wrote what it was, g prime equals f of x, and I would label my graph just so I know. Because then every time, everything that's going on right here, I'm thinking in my head the right things. So, when a graph is increasing and concave down, so this has to be increasing is what? So the derivative's doing what? Positive, so it has to have g prime of x has to be positive. And in order to be concave down, what else has to be true about g prime of x? Decreasing. And if you too bad, but I think the hardest part is making that connection, and then I would just leave it labeled. So this next one is just quotient rule, right? You need to find this. So finding h prime of x is part of it. I don't know where, well, I guess I look at the, see where you guys do it. So just the quotient rule. This part right here is going to be worth 1 point. So finding the derivative. And then the thing you have to be careful about is you got to know what everything is to plug it in. You have 5, you're plugging in 3 for your x. G prime of x, this is G prime of x. So whatever this y value is, that is G prime of x. So at 3, my y value is -2. Oh, and you had it, so that you got this as -1, and then that messed up everything, right? So since this is G prime, the G prime of 3 is just this y value, -2. And then, what else does it have? G of x. The nice thing about it is G of 3, that's the whole reason we did that, so that we have G of 3 right there. So you're doing G of 3 is 9, which if you got that wrong, then you're doing everything wrong. But it should have been an easy question. This is just area of triangles. Just gotta be careful. So then you just plug them all in, figure out what it is. This, find the slope of the tangent line when x equals 1. So you need to take the derivative of this and plug in 1, right? So this is where it's nice if you can do composition of functions to find p prime of x. You can write it as the derivative of the outside times the derivative of the inside. And then I've got to plug in -1. So -1, this is all without a calculator. -1 squared is 1. 1 minus -1 is 2. And -1 right here is -3. Okay, so I've got to find f prime of 2. So that is, looking at this, how do you find f prime of 2 off of this graph? I'm looking at 2. What is, this is f. F of 2 is 0, but what's f prime of 2? The slope of the line, the slope of the tangent line, right? Can I see the slope of this line? We've used it how many times? This slope right here is -2. So when you go down here to plug it in, you've got to plug it in -2 by looking at the slope. So they did this, and they plugged it in, got exactly what we got. Once you get, I mean, obviously you get here, you don't have to worry about, you can just write 6, but, you know, the place where you could have stopped if you'd like, you could stop when you get here. Once it's not in function notation or any integrals, you don't want to figure out what it is, because I know that's one of the hard things is making sure you add and subtract right. That's 6. This one. You have your train for question 4. Runs back and forth. Find the average acceleration. So average acceleration, this is velocity. And everyone was pretty good at just thinking, oh, velocity, average acceleration is change in velocity. You didn't have a function to do the integral of, right? Yeah. So you're just, oh, yep, I'm just going to use the table and you did slope. So that one was just slope. And it did want you to do the units. It's actually, they didn't give you points for that, but you would want to make sure you did that. You have meters per minute, so meters per minute squared. Do the slope. You could stop. You could write this first part, and you don't have to simplify, so whatever you get, it's not a calculator. You don't have to do, don't try to do like 33 1/3 or something, or whatever it is. I wouldn't do that. You can even just leave it -220/6 meters per minute squared. Just don't worry about simplifying anything. Unless you might need to use it for Basically, what's the intermediate value theorem? You have a y value here and a y value here, and it's continuous. And at some point, it's going to reach every y value between those two. Right? Pretty much. At some value. Is that all we have, though? This says something. It will fit it at some point. Okay, so this is half the point. You guys got one of the 2 points. I don't know if you looked at what wrong one. This one, the intermediate value theorem, that is awesome to say it, but you have to kind of explain it a little bit more. So you need to say what the intermediate value theorem is. You can't just say intermediate value theorem. We know that if this is 40 and then it goes to negative 120, and it does have to do with the fact that this is a differentiable function, so you know that it's smooth and continuous because it's differentiable. So, if not, it might jump around and have holes in it, and, we know that a train is not going to jump from something to something, it's going to go through all the values.
Just say that.
No, it's probably better to mention this. I mean, you could say it's differentiable, so it's continuous. And then you should say something about the fact that it was at 40, at time 5 it was at 40, and at time 8 it went to negative 120. So by the intermediate value theorem, it has to reach negative 100 at some time between time 5 and 8. They went like this and said b of 8 is less than negative 100 is less than that. So you have to mention some numbers. You can't just say intermediate value theorem. You have to say it went from 100 is between these 2 values. So it's somewhere right there by the intermediate value theorem. So make sure you don't just say intermediate value theorem or mean value theorem. You got to say like numbers that go with it. So this one at time 2, it is 300 meters to the east, and the train is moving to the east. Write an integral expression that gives the position of the train. So we have an integral expression is you're at 300, right, is where it was, and then at 2, and we're trying to find where it's at 12. So it's at 300, and then you do the integral from 2 to 12 of the velocity. And notice does that make sense? You gotta just do your starting position plus your change in position. And that would be 1 point for doing this part right here. Okay? That's 1 point. And then a trapezoidal sum. Remember, a trapezoid, sometimes it's nice just to kind of draw it a little bit. You can't remember, because all of our trapezoids were like this. We have 3 things right here, just so you can kind of remember what they looked like. This change right here was 3, and then the trapezoid well actually doesn't go with this, it should be going down. Sorry, I guess I'll do it this way. This was 100 and this was 40. So you have 1/2 times 3, and then 400 meters to the north. And you remember at time 2, the other one was 300 meters to the east, right? I told us above. So we need to draw a picture. They didn't draw a picture, but remember our whole, we're doing rates. You need a picture to go with this because we first draw through our dreads, draw a diagram. Okay, so I would start with a diagram. I would say this one was 300 over here. And actually, these are changing, so maybe I wouldn't label them quite yet. I would just say this one is over X, this one is of Y. Okay? And they're changing, so the things that are changing, remember you don't do that until you substitute it in. So, and then I have the distance between them is whatever you want to call it. I'll just call it Z because they did. So, if you write, hey guys, quiet. I just deleted what that was worth, but if you write this, I think that was worth 1 point to be able to write x squared plus y squared equals 0, e squared. There's my diagram. My rates are going to be, the nice thing about it is my rates are the velocity of train B at, does it tell you? Oh, I just have the velocity, v of t equals, alright, so let's just look at what they did. We have that, then you differentiate that implicitly, so that implicit differentiation, that's worth 2 points, 2 of the 3 points, just to draw it and do implicit differentiation. That wasn't that hard, right? 2z, dv dt, 2x, and you're doing with respect to time, so you gotta do it dx dt. That right there is 2 of the 3 points. That's fast. And it's not that hard to draw that picture. You just gotta remember, don't label anything with what it is if it's a change in rate. So that's awesome. All this other stuff is for 1 point. I mean, it's worth it if you have time. But they went through 300, 400, 500, find out what it is when it's at that time. And then the velocity at time 2 is 125. The velocity of the other one is off this table. At time 2, you have this one is 100, so you're plugging that in for the velocity. So you're plugging in 125, you're plugging in 100 for the other one, and this was 500 because that was the position. Solve it, and that will tell you the rate that it's changing. So that part was still not, it wasn't too bad, really. If you could draw the picture and get the picture, then you were set. Really. Okay, question number 5. Notice that they are both twice differentiable, so that they're continuous, right? And they're not going to be like any jagged points or whatever. This one, everyone is pretty good and agreed on that the critical numbers are where it equals 0, so it says x is the only critical number when the derivative changes from negative to positive, so it has to be 1. That was, you guys are probably pretty good at saying that, right? So you notice that and it tells you whether it's going from positive to negative, so you look for at what value was the derivative equal to 0, and it had to change from negative to positive to be a minimum. So that one was good. This one is going to be what? Why is the second derivative equal to 0 somewhere between negative 1 and 1? Here's the first derivative, 0. Here's this one. So if it's talking about the second derivative, what is it talking about? The slope of the derivative. So if you do this slope right here, then it's going to be 0 minus 0. So they gave you points by doing, and I don't, it seems like they still want you to say, like, if you're using the intermediate value theorem and the mean value theorem on both of those, if it's differentiable, then it's continuous. It's always differentiable is continuous, it's not going to throw anything off. So anytime you see differentiable, it'd be nice just to mention that, yeah, it's continuous. So the slope is 0. If you do the slope between -1 and 1 up there. And so by the mean value theorem, that one was the one where you said if it's 0, I'm trying to think of a picture that was 0. I could do it if it's not. Like if this right here, whatever this slope is right here, there has to be some value where the slope of the tangent line is equal to the slope of the secant line. So that's what the mean value theorem is. And it has to be somewhere between this x value and this x value. So right here, by the mean value theorem, there's at least one value in there where that's equal to 0. And answer your questions in a sentence when you get done. You can. So this is a complete sentence. Answer that one in a complete sentence. So this was nice, and we went over this just the other day, right? How to do composition of functions. Because h prime of x is going to be the derivative of the outside function. So what's the derivative of natural log? The derivative of natural log is f prime of x. 1 over f of x, right? Isn't that the derivative of natural log? Okay. Well, and then I got to do the derivative of the inside. Yeah, f prime of x, like that. Exactly. Yeah. Yeah, so you were saying that, right? Yeah. So the derivative of the outside times the derivative of the inside. So that was where you guys did f prime of x over f of x. That's probably better than what I wrote, but down here, and then you just need to plug in 3. So you do 1 of f of 3. So you just have to look at your table, really, right? This is just looking at the table, plugging in some values, and timesing it out. So, and if you ended up getting, like, let's say you did like 1/7 divided by 2 or something instead of that, I probably, if you got to here, unless you know for sure you're not going to mess up multiplying by the reciprocal, I would just leave it like that. Because what if you accidentally put 2/7 instead of 1/14? Or just remember, do not multiply by the reciprocal, you get that. But just be careful that you do it right. If you ever mess that up, I would just not do it. Mess it up before. Alright, so this one, how do you take the integral of this? This is just a pattern that you can see, but sometimes it's hard to see, right? To do use substitution. So I've seen some of you write out the use substitution, which is probably what I would do. That's probably why you do it, so it's not you. But like if u equals g of x, then what did du equal? G prime of x dx. So this right here became, and I would just maybe do this off to the side and then come back up to this. I would just be like, okay, I'm not going to mess with the -2 and 3 right now. I would come over here and say this is f of u. I remember when you yeah, last time you were going to be positive and then said that. Okay, so what is the integral of this? This one is, oh sorry, this was f prime of u, right? Sorry. What's the integral of the derivative of that? That would just be f of u. And technically, if I'm doing it off to the side, I probably should put plus c. I mean, they're not going to do that. Because right now, I don't have the definite integral. So I'm going to come back here and write it what it is right here. So I'm going to write, this just turned into f of g of x, right? Yes. So I plug it back in. And I'm evaluating that from 3 to -2. All of that just disappeared. The g of x, this is g of x right here. But when I took the integral, this was the derivative of this, so it just, I just put the x values. Oh, the x values, oh, you could rechange them, but I just wanted to go back to x, just, I don't know. This one I just go, able to sit there and pull numbers off that table. So let me look at those again. So f of g of 3 minus f of g of -2. Do you guys all know how to do that? Like, what is this saying to do? G of 3, so I look at G of 3, make sure I get the right one. So this turns into f of, what is G of 3? 3G. So you got it, this is a lot of matching up the table the right way. And f of, what is G of -2? So now I've got to go f of 1. So make sure you go, wait, 1. And I go f of 1, 2, and f of -1, 8, -6. So it's all just reading it off the table, but you've got to sit there and read the right things, because that's so easy to mess up the wrong. So all that attention to detail is what all that really is. Okay, so point-wise, if you knew to take the integral of this, because the derivative was there, and you got to f of g of x, that was one of the answers. Actually, maybe, so they're just, I don't know, they probably had some, so this first part, these first two lines were worth 2 of the 3 points, and then actually plugging it into the one worth 1. But getting the f of g of x out, and then doing that, subtracting it, I would guess that that was 1 point, that was 1 point. That's 1 point.
We thought it was too easy.
Yeah. Well, and I guess the hard part is the very last one's hard. It's hard. So look at this, the solution curve. You had to make sure you went through 0, 1. Try when you graphed it. You guys didn't go down quite as far. Let's look at what yours looks like. But it's okay. So, Ian, it looks pretty good, right? You think? Yeah? I bet they would give it to you. But this one's a little bit steeper down, because as you look at it, if you try not to cross very many lines, you suppose, if you look right here, you need to just make sure you're going parallel to whatever these are. So right here, okay, so you can kind of see it. Let's look at yours again. Oh, it's kind of hard to see. So every part, like right here, this line, this should be a little bit steeper. This looks like it's kind of going over. You know, see where these are like that? This is kind of going a little bit at an angle to it. But, and even like right here, you're flattening it out, but it should be, the same slope should be like that right there. At 0, 1, yeah, it probably did before I printed it, huh? Or before I printed it, yeah. Yeah, because it was supposed to cross there. I think it did get moved up and down. So, yeah. I can't remember where it was that you guys had it. But just be careful that you look at that. Just as you go, just try to make it be parallel wherever it's at. So that was 1 point for that, drawing that. So don't, I mean, I know when you guys are doing it, you had time, but don't spend 15 minutes making sure you get that perfect. Or don't even spend 2 minutes on it, you know? That should be kind of fast. B, write the equation of the tangent line at this point. Use the equation to approximate it. So you need a point, here's your point, and you need a slope. How are you going to find your slope? Yeah, right here. This is what your slope is. You're plugging in 0, 1 into your slope. So plugging that in. Let's look at that. Oh. You plug it in and you get this when you plug it in the 0, 1. So you get the slope is 2. So then you've got y minus y1 equals m x minus x1. So you have the point 0, 1 and the slope is 2. write the equation of the tangent line, you got that, which you guys did good. And then this is just saying that's the equation of the tangent line. It wants you to approximate this value. So remember that the whole reason we do tangent lines, like if I have something right here, and I have a tangent line right here, at this point they're exactly the same, but if I go over a little bit, my tangent line value is right here. It's really close to the other y value. So that's why they're saying use that tangent line to approximate that, is because the tangent line is close to the other y value when it's close. This is 0 right here. Then at point 2, they're close to the same value. So that's why I want you to even try that. So you just plug in that number. Plug in that number into that line. And if you want, just stop right there, right? I mean, it's not hard to look right for, but if you're nervous you're going to mess that up, just stop right there. So you get 1 point for the tangent line, 1 point for the other one. So you so far are up to 3 points is all. This last one, 6 points. So let's look at this, because they're going to make you do this. If you have one and you try to find y, you have to do the separation. So part of the points are going to come really fast though. So you have this equation, and it says find y equals, which is f of x, which is what this is the slope of. And you know this is the initial condition. So I don't know, a lot of you guys didn't get time to get to this part, right? So let's look at it. 3 minus y plus sin of x. So let's just look. You get to here. You have to separate the variables. Separating the variables, 1 point. That's easy. Right? And then you have the 2 antiderivatives. That's 2 points. That's 3 of your 6 points right there. That's fast. The quiz last time. So you look at this, you do the integral of cosine, you get sine of x plus c. That's another point right there. That's easy. This one you've got to remember that the integral of something like this is just the natural log of that, right? So with that negative there, you might want to do a little bit of u substitution, like let u equal 3 minus y, so that du equals negative dy. So if you can see that, all you're going to need is an extra negative there. So I'm going to need a negative right here, so it's going to put a negative out there. And then it's just going to turn into the natural log of that. So putting that negative there and doing the natural log of that, that's worth a point. And then after that, they plugged in 0, 1 to find out what the c was. So if you plug that in and you actually find that, well, if you just decide to use that, if you plain use that, they're giving you a point for plugging in 0, 1. That's good. So if you, these are the hardest two, to solve for it and to solve for y. If you don't solve it all the way for y, that's okay, as long as you start to separate them to the derivative, try to plug in the initial condition. You actually found it. That's good. So they went through, found it. And then after that, that was kind of a pain. And I ended up with it a little bit different when I did it on my own yesterday. But that's okay. Like if I just plug in c, so where do I get to? I come right here and I plug in c. Sine of x plus, well, I'll subtract natural log of 2. Just remember to undo the natural log. You just got to change it to exponential form. So you get to here. And they ended up putting the 2 somewhere else. But if you ended up with like plus the natural latitude right here, or minus whatever one it is, we can do plus. Instead of having this 2 right here, it's still a correct thing. I mean, it didn't have to be exactly like this. It would be nice. So if you're not sure, like, I don't know if you guys remember, but this ended up just being 2. Or e to the natural log of 3, that's just 3. But if you didn't make that step and simplify it, as long as it was equivalent, it still would be okay. That's what they did to get the limit. So that's kind of the hardest part of that one. Yeah. That. Yeah. So if you find the constant of integration, if you find the value of c, they're giving you a point for finding the value of c. And notice, if the most you can get is 3 points, if you forget to put plus c, then you're only getting 3 points at the most. Which makes sense because you get to right here. You separate it, you take that out of your derivative, you just mess up after that. So make sure you put plus c. So they're not going to give you this point if you don't have a c to solve for, which makes sense because why would you plug something in to solve for something when you have anything to solve for? Test.